Hey team, here we go again with section 4.5. This is day 2. So all the examples that I skipped in the video from last night, I'm going to go over tonight. And again, you'll want to probably have your calculator with me, like ready to go, so you can practice typing some of this stuff in, because that's one of the hardest parts of this section. But as you can see, there's a ton of examples in this section, which is why I split it up into 2 days. And each example, keep in mind, has kind of some steps off to the side of things to be thinking about and strategies to attack all these examples. So first one I want to do, we're going to go all the way to example number 4, because that's the one I left off with on the video for last night. Just kind of do this one as a warm-up. This is nothing different than the problems that we did yesterday in the video. Again, we would be trying to write these with the same base on each side, but you can't make 7 and 3 into the same base. So the whole purpose of logs is to be able to solve equations like this where the x's are in the exponent. So remember that the trick is to do natural log of both sides. Or you could use log of both sides, but I use ln just because it's one less letter to write. And that is what brings down all of the exponents in front. That's the whole purpose of ln here. Remember to keep those exponents as a quantity in parentheses. And just keep in mind, I know that this whole thing is pretty crazy with all these ln's everywhere. This is just a decimal in the calculator. This is also just a decimal in the calculator. And so what I'm going to do is continue writing ln 7 instead of writing that decimal, and I'm going to distribute that decimal to both of those terms in the quantity. So 2x ln 7 minus 5 ln 7. And again, same thing on the other side. 4 ln 3 plus x ln 3. And all of these ln's, you guys, are representing decimals. And instead of using the decimal in the calculator now and having to write that all down throughout the whole problem, I'm continuing it as ln 7, ln 3 through the whole thing. So we're trying to get x by itself, so this term has an x in it as well as this term has an x in it. So I'm going to move this term over to this side. I'm also going to move this constant term over to this side. So do a little bit of rearranging so that you can get your x's together. This is the strategy when there are multiple x's in the equation that you're solving for. So 2x ln 7 and then bringing over the x ln 3. Keep the 4 ln 3 where it is and bring over the 5 ln 7. So now I have all my x's together. You know how to finish the problem. Probably factor out the x here. So I have 2 ln 7 minus ln 3, 4 ln 3 plus 5 ln 7. Last thing to do would be just to divide by the quantity. That's what cancels here. Divide on this side. 2 ln 7 minus ln 3. So keep in mind from the video from yesterday, excuse me, this is our exact answer. And if you were to type it into the calculator, the approximated answer for x is going to give you 5.057. So something to be kind of thinking about here. Make sure that you are aware of how to type this whole thing into the calculator. You're going to have parentheses everywhere. You need to tell the calculator everything that's in the numerator and everything that's in the denominator. And you're just going to have a bunch of parentheses in this whole thing because the calculator opens up a parenthesis every time you hit that ln button. So see all of the parentheses that we have, including if there are multiple terms in the numerator, you need to have parentheses around the entire numerator. And on those TI-89 calculators, you can kind of look at it after you hit enter and make sure it looks the way it should. On the 83 and 84, it's a little bit harder to see that. If there are multiple terms in the denominator or in the numerator, you have to put parentheses around them. So there's a bunch of parentheses when you type these. It's very important that you are aware of how to get the right decimal answer for these. So make sure that you pause the video, give it a try, see me with questions in class. I'll be walking around making sure our calculators are all working appropriately. Alright, so that's example number 4, just kind of a little bit of a warm-up. Let's go to example 7. That's the next one that we haven't done yet. And I do have a little hint over here in the box. And that hint says that if a log equals another log, then that just means that the parentheses have to be equal to each other. So it's kind of like, remember how when we had those examples where we were trying to get 2's on each side, and when we had 2's on each side, the exponents were equal? So same thing, we have a log on this side, a log on this side. That means that this has to equal this. So very simple problem, but we tend to kind of freak out anytime we see a bunch of logs in the equation. So if there's one log on each side, that just means that the quantities are equal. So all we're doing is solving x plus 1 equals 4x minus 7. And that's because we have a log on each side. So I'm just going to combine my like terms here. I have 3x when I bring over the x, and when I add 7 to both sides I get 8. This means that x equals 8 over 3. So that's kind of example number 1 for today's video. Example 8 is the next one I want to talk about. So notice how we have a log and another log on one side and a single log on the other one. So the hint here is to try and condense the equation first so that it will look like example 7. What I mean by that is you can combine these using the properties of the logs that we already know. Condense. So since it's 2 logs being added together, that means that you can make it one single log by multiplying 2x minus 1 times 6, and keep the right hand side the same. Okay, so you can combine those 2 logs. That's the whole purpose of having these logs, and separating them out and practicing all that expanding and condensing that we did. This becomes log base 3 of, when you distribute the 6, you get 12x minus 6, and log base 3 of 4x. So now it looks a lot like example 7 up here, where it's one log equals another log, and in that case your parentheses are equal to each other. So after you condense, now we can use that same property of this parenthesis has to equal this one. So we're just solving the equation of 12x minus 6 equals 4x. So when you minus the 4x over, you get 8x, add the 6, and reduce the fraction. That gives you 3/4 for x. So we do have to condense and combine first if possible, and then again we have a log on each side, which means the parentheses have to equal each other. Alright, example 9 is the next one. What we're going to do here, and I have written in the box here, always check your answer. You can't log negative numbers. This seems fishy. So that's going to be a hint that we're going to use maybe when we get our final answer. But again, do you notice how these two can be combined? You need to condense those. We have a subtraction sign here, which means that I can condense them by using division. So x plus 4 over x minus 2. Keep the right-hand side the same. And now it looks like example 7, and it looks like example 8. What we're trying to do here is condense so that I have a log on each side. And when I get that log on each side, that means that my quantities are equal to each other. So I'm essentially just solving the equation x plus 4 over x minus 2 equals x. Again, that's because I have a log on each side. So I think, just going with the flow here, we're going to cross multiply. That gives us x plus 4 equals, when I cross this way, distribute the x very carefully. Since it's a quadratic, meaning it's an x squared, that means I need to have everything on one side so that it equals 0 so I can factor it. Subtract the x over, that gives me negative 3x. Subtract the 4 over, that gives me negative 4. We're going to factor x minus 4, x plus 1. That gives me 2 answers, one of which is 4, and one of which is negative 1. Now let's go back up to our box here and talk about maybe why they said we can't log negative numbers. Okay, we need to check both of these answers. So we have 4, and when I plug it in here, I get log base 3 of 8. That's not negative. When I plug the 4 in here, I get log base 3 of 2. That's not negative. And when I do log base 3 of 4, that's not logging a negative number either. When I plug in negative 1, though, you guys, take the negative 1 and plug it in right here. That's log base 3 of 3, which is not a negative number. That's fine. When I plug in negative 1 here, that's log base 3 of negative 3. And since you have your calculator right there, what I want you to do is type log negative anything. So hit the log button in your calculator and type like negative whatever number you want. Negative 1, negative 4, negative 7. What does it do when you hit enter? You cannot log negative numbers. It gives you an error. So keep that in mind. Think about the graph. We have asymptotes and stuff. You can't log negative numbers. You cannot in the calculator type log of negative any number at all. Therefore, this is an extraneous solution because we cannot log negative numbers. If you plug that one in right here or right here, you end up with a log of a negative number, which is bad. So teaching moment there. Keep in mind checking answers and making sure that we are not logging negative numbers. Okay? That was the purpose of example number 9. Talk about that one. Just have a couple left here. Example 11 and 12 both look a little bit different. So the goal for number 11 is that you notice I have a log on this side, I have a log on this side, and I have this random whole number. So the goal for this is to get the logs together on one side so that we can condense them. So what that means is I'm going to move this entire log term over to this side to join the other log. Okay, so when I do that, I'm going to have log base 3 of 2x minus 3 plus, because I'm moving the term over, log base 3 of x plus 1, and I still have that random 1 on the other side. This example is different from all the other ones because this term does not have a log with it. Okay, makes it very, very different. Remember all the other ones we were trying to get a log on each side so that we could just do parentheses together. But in none of those did we ever have a whole number, a random whole number. So still, what we know how to do here is condense. So I'm going to combine those. So that's going to be log base 3 of 2x minus 3 times x plus 1 because it's an addition problem. Okay, so condensing. Now what I'm going to do is FOIL in the middle part. So foiling gives you 2x squared minus x minus 3. And now again, this is a different type of equation that we haven't really focused on or solved before. But the goal for all the other ones was to get a log on each side. I can't just throw a random log in here. This is just a whole number. So the only other thing we know how to do, you guys, is to rewrite. Do you remember how to translate? Let's do that. Let's make it 3 to the first equals 2x squared minus x minus 3. And now there's no log in this problem. Whenever you do that translation, whenever it's log equals number, let's try and do that translation because then the log goes away completely and we can just solve like this normal equation. I'm going to move up here so I have a little bit more room. That means that 3 equals 2x squared minus x minus 3. Let's make it equal to 0 so that we can factor it. 2x squared minus x minus 6 factors into 2x and x. This would be a minus 2 and a plus 3. So I have two different answers for x. Negative 3 over 2 and 2. And again, we're going to need to check these answers. When I take the 2 and plug it in right here, that means 4 minus 3, which is 1, which is not negative. When I take the 2 here, that's 3, which is not negative, so the 2 works. Let's check the negative 3 over 2, which is negative 1.5. You plug it in right here, that means that you're logging a negative number, which you cannot do. So I cannot have this because it's going to give me a negative number when I plug it in right there. Okay? It would also give me a negative number when I plug it in right there. Either way, doesn't matter. So we end up with x equals 2 for that one. So this is a different example because we didn't have a log on each side. We had a random whole number. Do not forget how to translate. That is another tool that we know that's going to help us solve these examples and these equations. All right, number 12, last one. This one looks really crazy. It's a double log. And again, it's a log on one side and a whole number on the other. So whenever you see log and whole number, this is the last kind of example of solving problems we're going to do. Try and rewrite it. Again, just do that translation. Okay, and notice that every time you do that translation, the log kind of goes away. So I'm going to translate that. I'm going to take this 3 to this exponent, and it equals this middle part. Okay, so that's just a translation. This is a little bit, excuse me, strange looking because we translated it once. We still have a log, but we got rid of one of the logs just by translating it. Here's what the equation looks like. 9 equals log base 3 of x. Okay, still don't really know what to do. I have a log on one side and a random whole number on the other side. Let's translate it again. So that's going to become, don't forget the B-A-E. So the base is 3. Excuse me, the exponent is 9. The answer is x. Whoa, 3 to the 9th is an enormous number, so I'm just going to leave it like that, but I just got x all by itself. It equals 3 to the 9th. Okay? We're going to do a bunch more practice in class tomorrow, you guys. Thank you for watching. Make sure you bring your questions to class and your calculators, and we will figure everything out. At least you got your good notes down. We're going to practice all this stuff and figure it all out tomorrow. Have a great night.